Welcome back, my fine young schmetterlings. We're going to do a few examples with density together. A quantifiable physical property.
Chocolate. Jericho. Lorraine, my density has brought me to you.
What?
Oh, what I meant to say was...
Wait a minute. Don't I know you from somewhere?
Yes. Yes. I'm George. George McFly. I'm your density. I mean, your destiny.
Alrighty, so we've already looked at this formula. Density, or the fluffiness of something, is mass over volume. The mass is kind of related to the number of atoms and how they're arranged, and we'll see that a little bit later. And the volume is the space it occupies. Okay? It is a derived unit, grams per centimeter cubed. It's not a fundamental unit. It's made up out of two others, just like kilometers per hour is made up of two different kinds of unit. Now, I like to use the Greek letter rho. Row your boat. It looks like what you see there. It looks like the letter P, and it's the Greek letter rho. Is also commonly used for density. Why can't I use D? Because if you look it up online, you're going to see rho used all the time. By the end of my course, the blue Greek letters we'll have looked at. Though I goofed here. Not chi and psi. We won't do those. Just omega. So alpha, beta, gamma, delta, epsilon I'm going to use. And pi, you already know that I'm going to add rho and sigma. Not these ones, just omega. The yellows you'll learn by the time you finish high school. Do I want you to use rho when you give me density solutions? I don't care. You can. No, You can use rho if you want, or you can use D. I really like the rho better. D is just, it's depth. Okay? But in any case, use whatever letter you prefer. So here are two examples. I give you a 200-gram object. It occupies 20 cubic centimeters. Calculate its density. You give me a formula. Then you write out your numbers with your units. No buck-naked numbers in science. And then you give me an answer with units. And the same here. Now, what's the difference between milliliters and grams? Well, one is how you measure solids, one is how you measure liquids. So grams per milliliter is totally acceptable for a liquid, where it's usually grams per cubic centimeter for solids. What's with this being less than 1? That's totally acceptable. If you worked out your rate of pay and you got 80 cents an hour, well, that freaking sucks, but $0.8 per hour is a perfectly valid number. Resist the urge to flip it and force this number to come out larger than 1. It's a very common thing students do. I recall wanting to do it myself. So 0.8 grams for every milliliter means that if I gave you a thimbleful of this stuff, it would not weigh as much as 1 gram. This would be a test question. This would be as big as it would get on a unit test in chemistry. A box has dimensions of length 10 centimeters, width 40 centimeters, height equals 2 meters. Its mass is 50 kilograms. Calculate its density. Now, notice the sneaky little trick in there. Do you see it? Do you see it? 10 centimeters, 40 centimeters, 2 meters. Uh-oh. Can we do that? No, we can't. But did I do this correctly? You wouldn't believe how many students would go 10 times 40 times 2. But think about it, 40 centimeters. Now, is this done proportionally? If this is 2 meters, does that look like 10 centimeters to you? Or is the diagram creating that cognitive dissonance where it's tricking you into believing something that isn't stated here? So what I've done down here is I've converted everything to meters. And then I got decimal 808 meters cubed. Okay, and now we get a density of this, 625 kilograms per cubic meter. which makes sense. A cubic meter is about the size of my podium at school, if you remember that place, maybe 2. So 625 kilograms in a cubic meter, that's not unheard of. A cubic meter is pretty large. I could cram like 7 or 8 bodies in a cubic meter. Well, forget I said that. Now here's an example. If I give you a box 12 centimeters by 27 centimeters by 10 centimeters, and it has a mass of 1.2 kilograms. What is its density? Step 1, compute its volume. Give me that formula. It's not hard to do. And there we multiply it. I like putting things in brackets, square or round, doesn't matter. I've highlighted the numbers in blue for you, and notice I've kept the units. And I get this, 3240 cubic centimeters. Then when I calculate density, and I'm going to use rho. Row your boat. Density is mass over volume. There's my mass. There's my volume. I get a density of 0.37 grams per cubic centimeter. Ooh, and a mistake slid through. That should be an equal sign. Curses. It was so close to being beautiful. Now that we've calculated an example, what were you to do with this assignment? Well, let's say the one I just did was an example. So we calculated 0.37 grams per cubic centimeter. And if you look on this list of substances, the closest one is white pine at 0.4. So that's your answer. It's not going to be exact. You're talking the slightest mismeasurement, and it's wood. You don't think that's true for every white pine tree on planet Earth, or even every piece of the same tree. It's going to be very different. Even from the center of a tree to the edge, it's different. So you got to remember this value here. For water, it should be fairly close. But there are many kinds of steel. There's only one kind of mercury or carbon dioxide, but concrete, there's dozens of versions. So if you get a number like this, 0.37, and you don't see it exactly here, take the closest one you get, and that's good enough, okay? Now, I'm going to pause for a moment and let you see a video of me doing a hand version of the solution, which would be something you'd see on a test. Here's an example we can start off with that I'm going to use pen and paper here to help you get an idea of what you would be looking to do. When in doubt, locate all your measurements that are given. And by grade 12, they would expecting you, or grade 11, to do this. Itemizing them on the side never hurts. For many of you, it might be redundant. You already know, you spotted the measurements. And it doesn't matter which of these are the length, the width, and the depth. 12, 27 by 10. And the important thing is, there's no tricks here. These are all in centimeters. So your first step is going to be to calculate the volume. And again, we would prefer formula first. Then you're going to start with your numbers. And I'm going to give myself lots of room here. I'm going to bracket off the whole thing. And then I'm going to start putting in my numbers. 12, 27, and 10. And then we put pants on our numbers. Now this is just an illustration. I'm not interested in doing this to any exact degree. So you have to check with your other teachers on this. They may not be okay with this. I'm going to call that 10, and I'm going to call that 30. So in terms of straight numbers, that's 3, 0, 0, 0. I get an answer of 3,000. Now this is volume. A centimeter and a centimeter and a centimeter multiplied together. Let's just not change it from centimeters. Let's call it x. What do you get when you do x times x times x? Well, isn't that x cubed? So this will be centimeters cubed. You have measured on 3 sides. This is a volume. So you've done 27 by 10 by 12. It's a cubic measurement. Boxing it off for me is kind of nice. draws it to my attention. For you guys, I'll even do this usually. And then you've got it clear. Now, that's not the whole calculation yet. We've got to go back and write out the formula now. Density equals mass over volume is equal to, and we know it's going to be, I was about to write 1.2 kilograms. We can't do that. Kilograms are not acceptable if we're using centimeters. We need to turn that into grams. Well, that's really easy. What's 1.2 kilometers? It's 1,200 meters. What's 1.2 grand? It's $1,200. Get my brush. It's 1,200 grams. We want grams per cubic centimeters, not kilograms per cubic centimeters. So I'm going to go in here, and the mass on the top is going to be in grams, and it's going to be divided by cubic centimeters. And to help you see, we have a mass of about 1,200 grams over 3,000 cubic centimeters. You can do this on your calculator, but come on, let's it's the same as 12 over 30. Okay, 12 and 3, common denominator, there are 10 threes, and there are 4 in here. So I'm getting an answer of 0.4. So my final answer seems to be a density of 0.4 grams per cubic centimeter. And that would be the hardest question I would ever ask you on a chemistry test. That's the limit of the mathematics we do in chemistry. But I want you to be able to do this one cold. I want you to be able to calculate that showing these steps, and I will also show it formally in full printing. But again, if you walk in and see this complete, it's harder to follow than when you watch the steps. So I want you to do your next example on your own using this series of steps.